Okay, here we are. This is section 3-3, writing functions. So we're going to learn how to identify independent and dependent variables today and write an equation in function notation and evaluate a function for certain input values. Okay, the first part says we're going to determine a relationship between the x and y values and write an equation. So what's going on every single time to get from this x value to that y value? How do I get from 5 to 1? How do I get from 10 to 2, 15 to 3, and 20 to 4 being the same operation every single time? Okay, so in this example, what's happening is if I divide all of the x values by 5, I get all of the y values. 5 divided by 5 is 1, 10 divided by 5 is 2, 15 divided by 5 is 3, and 20 divided by 5 is 4. So to get the y values, we're going to write y equals, we're taking the x value and we're dividing by 5. Okay, that's all there is to that equation. So every time we're going to write y equals, and we're going to find out what is happening to the x to get that y value. All right, so here, what's going on from this to that? So if it is decreasing like it is here from x to y, there's only two possible options. You're either dividing or subtracting, right? If it's increasing, you're either adding numbers or, you're multiplying numbers. So here I could add 2 to get to 3, but 2 plus 2 is not 6. So since it's not adding, let's try multiplying. 1 times 3 would be 3, 2 times 3 is 6, 3 times 3 is 9, and 4 times 3 is 12. So this is multiplication by 3. So all we're doing with the x values is multiplying by 3. Okay, and the next one, it's a little bit different because we have vertical table, but it's the same concept. What's happening from every x value to the y? So it is increasing every single time. We are going to start with y equals. To get the y value, are we adding or are we multiplying? So let's start with adding. If I take 0 and add 4, I would get 4. 1 plus 4 is 5. 2 plus 4 is 6. 3 plus 4 is 7. So we're adding 4 every time. So this is just taking the x coordinate and adding 4. That's your equation with that one. Okay, so the next part says we have two different vocabulary terms. So the independent variable is the x values or the input. And the dependent variable is the output or the y values. There's a lot of words for y values, right? We call it the output, the y, or the dependent variable. So we call it the dependent variable because the value of the dependent variable depends on whatever the independent variable is, right? So here there's a relationship where we're adding 4. The y coordinates depend on what the x coordinates are. So if the x coordinate is 1, I know to add 4 to get the y. So this depends on whatever this one was. So that's why these are called the dependent variable. Okay, so here it says identify the independent and dependent variables in each situation. So it says a painter must measure a room before deciding how much paint to buy. So what are our two variables? We've got measuring a room, like how big is the room? And he's deciding how much paint to buy. So those are our two variables. How big is the room and how much paint should we buy? So which one depends on the other one? Well, the amount of paint that you buy depends on how big the room is, right? So that makes the amount of paint be the dependent variable, and the independent variable is going to be the size of the room. Okay, again, the amount of paint depends on how big the room is. It doesn't go the other way around. The size of the room doesn't depend on how much paint you buy. Okay, the room isn't going to get bigger or smaller depending on how much paint you buy. It's the other way around. You're going to buy the right amount of paint depending on the size of the room. Okay, the next one says the height of a candle decreases d centimeters for every hour that it burns. So we have two things going on here. We have how tall is the candle and how long has it been burning? So my question is, we've got time, and we've got height of the candle. So does the time depend on how tall the candle is, or does the height of the candle depend on how long it's been burning? And that is the correct one. Just so you're aware, time is always an independent variable because time goes on no matter what is happening, okay? So that's kind of a trick for you here. The height of the candle is going to depend on how long it's been burning, okay? The next one says a veterinarian must weigh an animal before determining the amount of medication. So the weight of the animal is going to be one variable, and the amount of medication is going to be the other. So which one depends on the other? Well, how much medication depends on what the weight is, okay? So the independent variable here is the weight of the animal because the amount of medication depends on how much the dog or the cat weighs. Okay, how much medicine you give the animal depends on its weight. Okay, the next one says a company charges $10 per hour to rent a jackhammer. So we have two variables here. We have the charges or the cost, and we have, again, how long it's been. So we have time. Time is always, always, always an independent variable, okay? And cost is always going to be a dependent variable. All right, so now we are going to talk about a function rule. So an algebraic expression that defines a function is called a function rule. Suppose Tasha earns $5 for each hour she babysits. Excuse me. Then 5 times x is a function rule that models her earnings because it's $5 times x, however many hours that she's babysitting. Okay? If x is what we call the independent variable and y is the dependent variable, then function notation for y, we call it f of x, or read f of x, where f names the function. Okay, so what's really important to know is f of x is just another way to say the dependent variable or the y. Okay, y is the same thing as f of x. They're the same. We're just going to be replacing the y with f of x, which means the function in terms of x. So that means x is the variable that is our independent variable. Okay? So again, y and f of x mean the same thing. So this little chart over here, remember how I said there's so many different letters and words we can say for x and y variables, right? So we've got independent variable. These are all the different words and letters we can use for the independent variable. The independent variable could be called the x values, the domain, the input, or just x if we're talking function notation, okay? And the dependent variable has all of these ways that we can call it now. This is it, I promise. There's not going to be any more. Okay, so excuse me, I've been recording for a long time this afternoon. The dependent variable are the y values, also known as the range, also known as the output. And if we're talking function notation, instead of calling it y, we can call it f of x. Okay. It says write each equation in function notation. All we have to do, you guys, is replace the y with f of x. That's it. So in place of y, we're going to call this the function in terms of x because x is the variable we're dealing with on the other side of the equation. So again, we're just replacing the y with f of x. That's all. That's all function notation is. So here again, if we replace the y with f of x, we're just going to keep the other side the same. And in this one, if I replace the y with f of x, the right side stays the same. Okay, that's all there is to function notation. In place of y, we're just writing f of x. All right, identify the independent and dependent variables and write an equation in function notation for the situation. All right, so here it says a math tutor charges $35 per hour. So these are just like what we did before. We're just going to add an equation at the end. So again, we've got cost and time, just like we did before. Time is always our independent variable. Let's call that T in this problem. The dependent variable is going to be the cost. Is that okay if we call that C? All right. So now instead of using X's and Y's, we're going to use C's and T's. So the cost depends on the time. The cost is our dependent variable. Remember, that is like replacing the Y value. So the cost, now remember, function notation looks like this for the Y. So the cost is going to be in terms of the time. So when we write this part of the equation, it's going to be C of T. And it's going to equal, now how do we figure out the cost in terms of time? It's $35 times the number of hours. So it's $35 times T, the time. Okay? So really all we're doing is adding, like the cost is equal to 35 times T. We're just adding this parentheses with T, so it's cost in terms of time. Okay, the next one says a fitness center charges, so again we have cost, $100 initiation fee plus $40 per month. So again we have time. So time, I'm going to use the variable T. The dependent variable is going to be cost again, which sure we'll call C. So since that's our dependent variable, we always write dependent variable and then parentheses independent variable, the cost in terms of the time. And now we have to write the equation. How do we figure this out? It's $100 just for the initiation fee, plus it's $40 per month. So $40 times the time, times the number of months. Now, if you wanted to use a different variable here, you certainly could. You could have used like M for number of months. That's totally up to you. All right, this next one says Stephen buys lettuce that costs $1.69 per pound. So here we have cost and we have pounds. So the cost is going to depend on how many pounds you buy. So the cost is our dependent variable, which we can call C. And then we're going to have weight for our independent variable, which we can call W. Okay, so we always write this as dependent variable in terms of the independent. So cost is in terms of the weight, or the cost depends on the weight. And our equation we would write is $1.69 times the weight in pounds. Okay, this one says an amusement park charges a $6 parking fee plus $29.99 per person. So again, cost comes into play, and cost is going to depend on the number of people that we have. So again, cost is going to be our dependent variable, but this time it's going to be the number of people that we have in the car, or along, I should say, which we'll call P for number of people. So for the equation in function notation, we're going to start with the dependent variable C in terms of the independent variable. So the cost depends on the number of people you bring. And it's $6 to park plus $29.99 times the number of people that you have. And there's your equation for that one. Okay. One more type of problem here. Evaluate the function for the given input values. This part's actually really pretty easy. So it says for f of x equals 3x plus 2, find f of x when x equals 7 and when x equals negative 4. This is just a complicated way of saying plug 7 into this and then plug negative 4 into it and see what you get out of it. Okay, so here we have our function. We're going to use that for both. So f of x when x equals 7. So I'm going to rewrite this function, but everywhere I see the x, I'm going to put in a 7. So f, when I replace a 7, is going to be 3 times 7 and then plus 2. All right, 3 times 7 is 21, and 21 plus 2 is 23. So f of 7 is 23. So it's just saying when I take the function and I replace 7 for the x value, this is what I get out of it. So again, it's like thinking 7 is the input, 23 is the output. Okay, so f of, now that we also have to do -4. So I'm going to go back to this original equation, and I'm going to take 3 times the -4 and then add 2. 3 times -4 is a -12, and -12 plus 2 is -10. Okay, this next one, they're just using different variables. Don't let it freak you out. So g of t is equal to 1.5 t minus 5. So we're going to take g, and the first time we're going to substitute 6 everywhere we see the letter t. So we're going to have 1.5, and then in place of t, we're going to put 6, and then we'll subtract 5. 1.5 times 6 is 9, and 9 minus 5 is 4. Okay, we're going to take the same equation, g, and we're going to substitute -2 this time. So I'm going to rewrite everything and just replace the t with a -2. Okay, if you're to evaluate that, 1.5 times -2 is a -3, and -3 minus 5 is a -8. Okay, the next one, the function that we're dealing with here is g of t. Sometimes we use x's, sometimes we use t's, sometimes it doesn't matter what the letters are. G is just the name of this function, just like f is the name of that function. So again, g of t is like the y values. So we're going to take g, but this time we want when t equals -24. So I'm going to rewrite this, and just everywhere I see a t, I'm going to replace it with a -24. So g of -24 is going to be 1/4 times -24 plus 1. Okay, 1/4 times -24 is -6, and -6 plus 1 is -5. And then I'm going to do the same thing, except I'm going to replace t with 400. So 1/4 times 400 plus 1. 1/4 of 400 is 100. If I add 1 to that, I get 101. Okay, and then the last one, we just have a different function with the letters h and c. H is like just the name of the function. C is my x value, really. So h, the first thing I'm going to do is replace all the c's with a 1. So h of 1 is 2 times 1 minus 1, which is 1. And then if I take h of -3, I'm going to have 2 times -3 minus 1, which is actually a -7. Okay, function notation can be a little bit tricky at first, but you just need to know that really all it means is y. Like h of c like this means find the y value when your x value is this and this. All right, please let me know again if you have any questions.